Well, I'm Glen Jarvis. I won't go into a large explanation of who I am. Time is a little short. There's a repo which will have a description of what I've done besides organizing and talking, and I do training videos online and things like that. And I've written a little bit of Python code over the years. So let me just go ahead and start off and just explain. This particular talk is important to me. I think this particular talk is important not just because Git is interesting, and I totally will. I'll put my pocket protector in and geek out. I'm sure I will at some point. You might even have to say scrat loudly to tell me to slow down, like the little, if you know scrat off of Ice Age, the little squirrel. I can sometimes do that if I'm not a little calmed down while talking. So anyone yell scrat, that's quite okay. But it's important to me because this particular topic of Git is like a lot of engineers don't use Git very well, and they should. I believe that if we all as engineers learned how to use Git better, we would actually be more effective. I want to help everyone do that. I like helping. I want to help have everyone here do that, and that's why it's important to me. How am I going to do that? I don't believe you're going to learn everything on the internal ever, always, but we can start with a ripple of change. We can actually start saying, look, this is actually how it works under the surface. And I love doing this as an interview question. I'll come up and I will say, when someone's interviewing with me, I will actually explain, what we're going to do today is I'm either going to teach you something or you teach me something about Git. And I usually end up teaching it to them. And it's great because I get a chance to explore all the things that they're doing. At the same time, I get to see the light bulbs go on at different times. And that's really interesting. This group is actually small enough, we might be able to get some of that dynamic. Usually in the larger group, it's harder to do. But that's actually what's the most exciting for me. So if we can get this interactive and we get this working so the demo works, it'll actually have a really cool dynamic when we start seeing light bulbs go off. It's not as hard as you think, really, once you understand underneath. But let's set the stage for a couple of things. You need to know a few basics or it's just going to probably go over your head. So what's Git used for? If you're just like, well, what do I use Git for? What's its purpose? Probably this isn't the talk for you yet, because if you don't already at least know what Git's purpose is, none of what I'm going to say today is going to make sense. How do I check in code or anything else, or how do I look at the Git log? If you don't even know what Git log is, this probably won't make sense at all. And the idea, even if you're using Subversion or something else, just the idea and concepts of branches and commits. So if you don't have that already, I won't be offended. We'll give you a few moments here to go find another talk. But what you shouldn't already know, and I actually had, last time I gave this, it was a room to about 300 people, and someone in the back was always interacting because I try to make it very interactive. Like, great answer. I was about to ask that one next, and so if you already know everything I'm about to say, if you already know what, for example, where the Git repo is stored locally, and a lot of people sometimes do that, that's all right. If you already know what head is, well, not just the concept, where to find it on disk. If you actually know how to find refs and what they mean and how to go find them, and if you already know what objects are, how to go look at objects, look at type of objects, and pull out objects and look at those too, and then how to interpret how objects are pointing to each other, if that's already super clear to you, this is going to bore you to tears. That's all we're going to do today. We have some code to try to do the same concepts, but really it's much more about the concepts first to explain it to you, and then see the light bulbs come on, and then you'll actually realize that the code is super simple. It's even trivial. So with that said, what you are going to learn is how Git works on the inside, how you could open up underneath and look inside of Git, and then all of those really cryptic commands that confuse us all the time, suddenly be like, oh, that makes sense. There's that light bulb. And you'll understand what's happening underneath, which I think that bit of clarity really just changes the entire process of working with Git. So if this talk isn't for you, there's some 3 awesome ones right over here. Flask is right around the corner, Evil Hacks as well, and Practical Introduction to Airflow downstairs. I would not be offended if anyone wanted to leave. I know that you have to kind of go here, so take a few moments. Yeah? Seriously? No? Surprising. Okay, cool. All right, then those of you who decided to stay, it's time for your first quiz. So imagine that you have a brand new computer. Let's call it an Apple. It doesn't have to be, but it's just easy to say I got a new Apple laptop. I have not installed anything. I've not cloned anything. I don't even know what that is yet. All I've done is opened the lid, gone to a particular directory with the terminal. Oh, and by the way, this will be almost all terminal today. So if that also bores you, I won't mind. So I've opened the terminal and I've typed Git Status. What do you think the answer will be? Do you think that, what will Git tell me? Will it tell me A, B, or C? And I'm hoping somebody says C. Somebody gets it. Awesome. So who thinks it's A? Please raise your right hand, or any hand. Wow, I have one vote. Cool. I think I must have made everyone think it's B. Who thinks it's B? Oh, wow. So for the video, most of the audience has raised their hand. The answer is both A and B, actually. And the reason why is because it depends upon the version of Git. But those who've raised their hand on B, that's actually what, I can tell you it's a bunch of old timers in here. Awesome. That's what I like. That's the kind of message that you would actually see. It happens to be that newer versions of Git are being super nice, and they're actually saying, okay, nothing to commit, create copy files and use git add to track. Oh, they're actually telling it. Git commands aren't so cryptic anymore. But if you think about it and look at it, B is actually much more, if you understood the internals, makes a lot of sense. It's saying this is not a Git repository. I'm checking because I'm looking for a .git subdirectory wherever you are. And then from there, I'm going to its parent, and I'm looking, and I'm going to its parents, and I'm looking, and I can't find any other way up. So you can tell from the message that it seemed really cryptic, and it is. But if you understood under the hood how it's working, those messages will make more sense. So great job, everyone. A and B is awesome. Let's do another quiz. All right, so now I have a brand new computer. Nothing else was cloned, but now I decided to open a terminal, make a new directory, and I typed git init inside of it. Now typing git init inside of it, some of us might know that creates a new repo. And inside of that new repo, it'll also have that .git subdirectory, which we'll get into in a second. So what do you think the git status will be here? How many people think A? I'm not getting anyone falling for the subversion answers anymore. All right, so B or C? How many people think B? I have 2 votes for B or C. Okay, any votes for B? 1 vote for B, and someone else says C. Interesting. So everyone was an old timer in the last question, but everyone's a new timer in the new question. So, which is awesome. The B, both B and C are answers that you would get. So B is actually what would be in the older versions of Git, the ones that we're used to. And you think, what? I don't even understand what that means. Fatal bad default revision head. Well, we'll soon actually understand that. Because once we understand the data structure underneath, it'll actually make more sense. So actually, please remember the answer B, fatal default revision head, because I'll be asking that in a few minutes when we start doing some live stuff. Even though the message won't be the same anymore, that's why we have to remember it. But the actual C is actually what it's doing now. People are being nicer in Git, and they're saying there's nothing to commit. So even though it's a brand new initialized directory, I see some furrowed brows, which is awesome, because that's actually what I want to go for, because when we show the next part, we'll see some light bulbs come on. So even though you've not committed anything, it still gives you an error message. So what have we illustrated? We've illustrated that, good software design, what most people would consider good software design, is you take an abstract concept in the world and you model it. You say, this is how things are. Here is an attribute of it. Here is a method of it. So it's often cars. So I have a particular car, and if I press the accelerator, I push on the accelerator, then it's actually going to increase my speed. So I could have some kind of method called accelerate, and then some kind of attribute called speed. But actually, that is how most software is designed, but Git is not necessarily that way. Git's much more about that particular image of somebody who's in a great, some wire over here and a wire over here, and you understand the engine underneath. You have to really understand how Git works. It was designed in a different way. It wasn't designed to be, hey, let's make this great thing so everyone can understand it. It's designed to be like, you are programmers. We're designing this as programmers. People know data structures. If I understand that data structure, then I'll just manipulate that data structure for the commands, and I'll just have something around it. So this is one of those times where it's like, understand how it works, and the whole thing makes more sense. So we're going to be looking at the engine underneath, and I forgot to set time. I will need a little bit of help here. How far are we in? Well, I'll need this for later. How far are we in?
About 5 minutes.
Okay. Sorry about that. Oh, so let's just make it 35. That'll keep me at least somewhat honest. And of course, now I'm all nervous. I don't know what to do. I'm just going to restart. Reset. Okay. I will definitely need some help with time. So I'll have to have some time checks a little bit more often. So this particular one, what we're going to look underneath under here is we're actually going to look at a live demo underneath. And what we're going to do is we're going to explore this with live code. Okay? One last attempt. Great. That'll just be so that I can stay somewhat on task. And we're going up a little bit so that this will be on the screen so I can kind of, because this is going to be very organic. The rest of it's not presented. It's going to be talking to you and helping you go through this. So we're not going to use the what's cloned already, but just to prove that this is really real, I need someone to give me a name of a directory. I'm going to make a new directory. Someone give me a name so we can tell that that's really there. That I didn't make this up ahead of time. PyBay. Now I could have made that one up ahead of time. What? Monkey. I like monkey. PyBay is good too, though. All right, so I've made a new directory monkey. And so if I go to monkey and I'm typing, what was it I said I would do? I would just type git status. We would already see the first thing that we would say, the message would be again. Fatal error, no directory. Good. So we're actually saying, look, there's no .git. So the first thing we're going to learn from this is that .git's where it stores everything. Okay, great. We already kind of knew that. Awesome. So now I'm going to actually do git init, and what that's done now is created an empty, and that's the key word, empty directory here. And that's actually going to put everything, it basically makes a .git subdirectory, but it doesn't put anything in it. There's no commit yet. So now if I type git status, it gives us this message that looks like it's all great, but the old message used to be no default revision head, and that's what I wanted to remember. Why? Why would it complain about head, or what's it being extra nice about doing here? So underneath the .git directory. Oh, and by the way, I'm going to give everybody all of this material. It's already, that's why I had you clone it. I'll have videos already ready that are there. I also am going to give a new course that I'm making for you for free. So everyone, as long as you pay attention, you really don't have to keep notes. It should all be available for you, but if you can, if you like. So there are really, this is the .git subdirectory. How many people have already played in this before and knew it existed? Oh, okay, good, awesome. So how many people played with the config, maybe, I'm guessing? Config file? Okay, 1, 2. So people knew it existed. We had a config file. But did we ever see head? That particular thing there? Okay, some people already know this. Uh-oh. Objects and refs. All right. So we already have these three things that we're going to explore. So if I were to look at this head thing, if I'm looking in .git and I say, look, let me look at its head. Here's the part that people always thought it was always stored in some really weird, hard to see way. But really, this .git head thing is really just a file. It's a file I can read. So far, could I have written this in Python? Could I have written something in Python that looked for a .git subdirectory? If it didn't find it, just progress up to the parent directory. Super easy. Nothing hard. It's not complex code. Now, inside of here, we have another file. It's a simple file. It's a text file. I can just cat it. Again, I could have just read that simple text file with Python as well. So really, I've just read that Python file. Now, what is this thing? This head is really a pointer to the branch. So it's a pointer to the branch head. All right, so here you happen to have a reference to refs, heads, masters. We know what refs was. We saw refs before. So if I were to look at this again and see refs, I would see there's something called heads in there. Cool. So ref, heads, master would be what it's trying to look for, because head's pointing here, but it doesn't exist. Does it make sense why that old weird message of default revision, bad default revision head was there? Basically, we said when it's just initialized this directory, brand new, it's a great, here we go, new directory, here's a master branch I've made. Master branch is pointing right here into this part of heads, and I go to look for it, it just doesn't exist. It doesn't exist because? No commits. Thanks, Alex. So there's no commit. So there's nothing there, and that's why we can't go any further. So let's just go ahead and just touch a file. I'm just going to call it PyBay. Actually, let me go ahead and put something inside of it too. PyBay1. PyBay. No. And this is my talk. Just something in the file. Okay, and now I'm going to just add that, and I'm going to commit that. This is my exciting first. No, I won't. I'll actually just use the proper syntax of add first commit at least. At least it's in the right format. And now, do you think I have changed the head variable? Here's another quiz for you. Have I changed the content of that at all? Yes, no, maybe? No? You're right. No, good. All right, so I haven't changed that at all, but have I changed this? Oh, shoot. Well, That's no fun. All right, so I did change that. So what is inside of yet another file? So there really is a head now, and it happens to be this long hash. I won't go into an explanation of how SHAs and hashes work. It's just a large bit of characters that represents that particular commit. If I was doing a git log, I would actually see that there's every commit message has this long hash, or this long set of characters. So there is a long set of characters. So cool. I can now see inside that Git's a lot simpler than I thought. I could actually start exploring when I got confused or broken in Git. I could go in and I could say, inside of the .git directory, what does head point to? It's actually something that points to refs heads master. What does master point to? All right, so far, does it too slow, too fast? Everyone getting it so far? Yeah, it looks like lots of, okay, awesome. So now, where do you think, so there are 3 things we're exploring today, heads, refs, and objects. So what do you think we're gonna go to next? Let's look at objects. Oops. So inside of objects, I'm going to see probably that full hash, right? Oh. Oh, wrong command. So inside of objects, I'm going to see that complete command. Agreed? No, I don't, but there's something similar. What's similar to what we were looking at when we looked at master to what's in this directory as well? And you can ignore info unpack. That's special. We're looking at unpacked things. It starts with D2. Very good. So if you look at the very beginning of D2, you could actually go find a commit object inside of disk. So why would we be able to start something with two characters instead of the full hash just to make it confusing? No. Because there's a directory, like if you're going to have thousands of these, every directory is going to have a certain limit of how many you can have. So if you want to try to cut that down, like we'll just take the first 2 characters off and then we'll put them over here. Or another 2 characters off and put them over here. These are called loose objects. They're very easy to get to. You just take the first 2 characters off, and the rest of it is the file name underneath. When you have really large repos, like a couple of ones I'm working on at work, you actually can get into an error where it says, we're actually having a hard time. There are too many loose objects. You know, you need to prune or you need to get some cleanup and stuff like that. But basically, you can have a lot of things in here. So let's look into, we called it D2. And sure enough, it's the file name. So everything we've seen so far has been very accessible. I could write it in Python, but honestly, it could be any language. You could write it in a shell script. I just look at .git directory, I find head. Inside of head, I actually go look for refs. Inside of refs, I find the branch. If I switch branches, it would be different. Inside of the branch, then I go find the object, and now I found the object. So could I particularly, everything has been text except for this one. Now we're into a binary world. So we now are a little broken. We can't do everything. Here's where we have to cheat just a little bit. All right. So I said we're going to do this without the git command with one caveat. This is our caveat. Whoops. This is our caveat. This is what we're going to be using to be able to examine that command. Because it's in binary stored already, so git underneath is actually going to say, hey, look, I'm going to just go ahead and interpret that for you. The problem is this cat file command doesn't look at files. It's actually, it already, since Git's doing it, it says, just give me the hash. I can figure out how to find the file for you. I just wanted you to know where the file was so you could associate these things and realize it's not that hard underneath. So if you actually look at the file itself, it's a commit. All right, so there's how you found the commit object. So you're looking inside of a git cat file -t. You actually look at the object, and there it is as you can basically see the object itself as a commit object. So we found it on disk. It was that file name. Cool. How do I look at it? There's one more option here. Instead of seeing T for type, I'm going to say P for pretty. And then I've almost pretty much uncovered all the tools that I need to be able to do this in Python. This is actually what the commit object looks like underneath. How do I find it? I went from git head. Inside of git head, I looked in the refs and found the particular reference from that branch. From that branch, I actually went down and I found the object on disk, and I looked at, and I opened it up and looked at it, and this is what it looks like. So some interesting things there. There's something called a tree, which is actually a pointer to everything on disk. So if you want to basically say, what is my, this is like a directory on disk. If you want to reconstruct your entire file system from this commit, you start with the tree and just follow all the tree and blob objects, and pretty soon you have the entire directory. So this is how Git handles it. We don't have time to cover that today. But we do have a couple of other things like author, and did you know there was a committer? Has anyone ever seen that before, a committer? Yeah? So we have a get and an author and a committer. Why would I have two? Why would the people, this is more of advanced, but why can we have two? Why, what kind of command would what if I took somebody else's commit? What's the command where I take someone else's commit and huh? Oh, if I did you're thinking, I think, I was going for cherry pick. But I think you were thinking, oh, no, sorry. You were thinking of that, I think, yeah? Yeah, but that would actually change the author itself, not the committer. So the committer is still me. The author, I could still change the author of someone else, but yeah, cherry pick someone else. Their author stays the same, but my commit changes. Very good, awesome. So that's why we would have different authors, and this is just plain text. There's no security to keep me from changing it. It's just text inside. And the committer is this stuff that I have registered for myself. So pretty much all of this is really super simple, except what? Timestamp, good. So we have a timestamp. So really, if you were following along right now, trying to do everything else, would you have the same hashes that I would have? No, but I could use the exact same file with the exact same content. You could even put my same name down as the author and committer. But you probably are not going to get the exact same timestamp. It's really rare that you're going to get that exactly the same, so the timestamp would be different. And now when we start understanding things like this, we start saying, oh, so if I'm cherry picking something from someone else, I'm getting a new timestamp. That object isn't changing, the old one is still in there. But I made a copy of one with a new timestamp, so I now have two objects. So those are the things that we can uncover as we start looking underneath and seeing what's happening underneath of the surface. All right? But that is actually what a commit looks like. Cool. But there is, and this of course was the message I typed, but there's something very sad. This has no parent. I feel sorry. It's kind of orphaned. Let's give it a parent. All right. Another file. Let's just touch file. This is an exciting name. Okay. So we've done a lot of changes. I added another commit. So, oops. Head. That's what I was looking for. Has head changed? Nope, I see some no heads. Good. Why hasn't head changed? We didn't switch branches. It's still here right at master. Great. And so if I were to now look at .get refs heads master, has it changed? Yes? Yes, it has changed. And so let's go look at it. Get cat-file -p. We'll look at that particular option. If we wanted to do a T first to show that this also is a commit object, look, it's a commit. But let's look at it and let's see what it is. This should be the first commit or the second commit that I did. Any guesses? Second commit. Cool. So it's the second commit. So now it has a parent. So tree, we've already talked about it. It's like the file structure. It would have two files now, not just one that it would point to. But there is a parent, and the parent points to the same old commit. What drives me crazy is that sometimes people will actually in the books, again, are you modeling things by our user experience? Or are we modeling it by how Git's doing it? Sometimes people will say, I will commit something and I'll point it to another object. I'm going to commit something and I will point to the next object. So usually they're arrows pointing forwards. But look at Git. It's not pointing forwards. It's pointing backwards. So that's really a get log right there, very close to it. So I very much started with the very top thing. I said, hey, look, there's tree parent author committer. Then its parent was D2. So the first commit was add file 2. And the second commit was add file 2, but the one before it was add the first commit. So really, if you want to look at how Git's modeling this, it's actually, I know, it's a little further like, what? This is how it's structured underneath. But once you understand that, then all kinds of things start making sense. Is there a question before we go to the next piece? Nope. I see a lot of furrowed brows and looks going, oh, that's just weird. Why does it get do that? But now you can actually, yeah. Parent is always the previous commit. That's right. So every new commit comes on and points to its parent. Think about how efficient. Git is incredibly efficient, such an elegant data structure underneath. I start a pointer out in the very beginning, it pointed to nothing. But then I made something and the pointer pointed to it. I make a new thing If I had to change everything, I would have to just keep changing these commits all the way up, but I don't. I leave everything alone, I make a new commit, and then I point it back. So I change this pointer to point to a new commit, make a new commit, and point it down, and that's it. Super, super efficient. If I want to make another commit, I have two things here. I make a new one, put it here. That points to that, points to that. I get three things. That points to that, points to that, point to that. Cool. And if, we might actually have time to do branches, but if we do branches, okay, I see a lot of like, okay, I'll have to try to rush a little bit more, but I think the audience seems really receptive to this, so I will pick it up just a little bit faster. All right, so if we make two branches, we can actually see what that's pointing to. Let's actually go ahead and make another branch. First of all, do I want to make a branch here or make another commit? Yeah, I'll make one here. So I'm going to make a new branch. Nope. Don't do all the combined. Do it one step at a time because we want to not confuse people. So git checkout, git branch. I'm used to making a shortcut there. Git branch and a new branch name. Island. Awesome. Okay, so now, what do you think this points to? Master? Oh, awesome. I see a lot of people saying yes to master. It hasn't changed. Exactly right. Good. It hasn't changed because we made a new branch. So what does that mean? I didn't get you guys to say yes, it changed. Instead, actually, if you look at git, refs, heads, there are two heads in there, both island and master, but only master is being pointed to because I didn't change branches. Make sense? Cool. So what is the content of island? And what is the content of master? Oh, that's okay. It'll still work, but you're right. That's probably not the... Okay, so what are those two things going to give me? The same. Why are they the same? Because the actual two branches both pointing to the exact same spot. I could have 100 branches pointing to the same spot. They're really just two branch pointers. I haven't changed anything yet, and I haven't advanced something yet. If I right now added a new commit, so I have one commit, I have another commit. If I added a new commit right here, what branch would be updated? Master. Good. So what would island be pointing to? Island would not be updated. It would be pointing to another one. So already this data structure is making a lot of sense. It's like, oh, this is so simple. If I get stuck and get hell, I can simply just say, well, what do things look like? What am I pointing to? Where's head? Where's that commit? Can I follow its parents down? Can I actually just see what's happening? What happened? How can I untangle that? So that's actually what's going to go on. And let's go ahead and let's just do that particular one. Touch file 3, get, whoops. I think it was file 2 anyhow. And let me just say, whoops. What did I just do? Oh, I did? I thought it was only file 1. Okay, then let me just touch. Thank you for that. Pair programming is awesome, especially because I make a lot of mistakes. All right, add file 3. Okay, what does this look like? So quickly, let's just start going through this again. So what is head? Head is fine. Head is pointing to the same thing that I was pointing to. What is refs? What is heads? What is master? We'll look at the actual commit there. By the way, anything I'm doing, system commands, reading file contents, really that's like a super simple Python to write my own git commit and my own git log. In fact, if I were to do the same thing, but take this parent, and then do the same thing, although I should just not backspace that, but let's do this parent. And I just keep going on parents, right? Oh wait, I can't go anymore because it's my first one. There's no parent for the first one. So here we go. I'm working backwards. There's a git log, and I have 3 commits for master. But if I were to check out island, what would be the first 3 characters of the commit that it points to? If I check out master, what is the first 2 things that it would point to? First 2 or 3 characters it points to? Be brave, someone. See, it's easy. It's super. It might be 80, but I don't think so. No, I don't believe it. Oh, it is. Yes. Yes, it was 80. Sorry, I was thinking it was wrong for a second. Let's check. Git, so cat.git refs heads island 80. Awesome. So it makes sense. These are how the whole directory structure and everything works underneath. So if we wanted to, we could actually continue on this whole process. We could look at .get. In fact, I actually have started another small file. It kind of broke some PEP8 standards. I'm sorry, now it's not called PEP8. It's called the, I'll say PEP8 standards, because I put everything in one file simply because I wanted to be able to make it really simple so I could run the command. So if I were to go look at this directory that you've cloned, there's some branches already there. And those branches could take you through each step of the process. So if I were to go basically say, hey, look, how do I find git root? What's the algorithm for that? I start looking for a .git directory. It's not that interesting, really. I just say, in my current directory, do I have a .git subdirectory? No, let me go to its parent. No, let me go to its parent. Nope. If I have nothing, then I'll just complain and give you the exact same error messages I had before. Otherwise, I would just say, I should make this executable, but I didn't. Whoops. So this particular bit of code is simply going to print out what the current .git subdirectory is. So you could start there. And that code's not that interesting. It really simply just starts working, finds the root, basically just says, do I have a .git subdirectory here? Do I have a .git subdirectory? If not, then I go back up to my parent, and then I just keep going until I hit root. Yeah? So if I were to say, whoops, get a little excited here. I'm going to now check out the next branch. I should make it slow as fast. Okay, there we go. And if I were to run the same command, we will see that this particular one is really just going to print out, hey, the contents of head is this. All right, so that's the same thing. So we really can do this in Python or anything else. If you want to look at the code really quickly, can. I don't think it's that interesting, and we have 12 minutes left, so I'm going to give a choice for path. Do we want to look at the code that we've done for this? I actually think this audience's level is pretty sophisticated, so that the idea of looking at these simple Python commands of doing a cat file, doing a system command for the get cat file, or opening files, is just kind of basic. So skip that part and move on to something more interesting, because I have a couple of caveats. Good. What's this tree thing? We talked about trees. So let's go back up to the commit that we made. Monkey. Inside of monkey, I said there were some cool things. And I actually said, hey, cool. Inside of .get, inside of objects, we're going to ignore info and we're going to ignore pack. Oh, and I've made a few now, so it's even more confusing. So how many commits do I have on all of my branches? So the same commits are on both island and on master. So I have 2 commits there, but they're the same commits. I didn't duplicate them. That would be inefficient. So those are 2 commits there. But then on master, I have a 3rd commit, right? So I have 3, what? 1, 2, 3, 4, 5, 6, 7, 8. Interesting. I have more things here. Anybody? So well, what are these things? So if I were to look here and say that particular thing, I'm going to say whatever that was, I know that this must be a hash. Does that make sense? I just reconstructed the hash from it. What is that? That's a tree. Now, I didn't know before I pressed enter because it could have been something else, but that happens to be a tree object. What does a tree object look like? Let's see. Cool. It looks almost like a directory structure to me. File2 is the name of a file, and PyBay is the name of another file. So I really could reconstruct the file system right here by simply saying, hey, that's a file. Let me recreate it. Let me touch that. Let me touch that. But wait, they have these other commits. So one of those files has some content, and the other one is empty. So those files have blobs. So if I were to say, what is the content of file 2? Whoops. Nothing. Because that particular file didn't have anything in it. But if I were to say, what's the content of PyBay, sure enough, that was where I said, this is my talk. So the little bit of script that I gave you really just shows you the Git log. All it does was start at the very top, find the head, and find your .git subdirectory, find your head, and then just walk through the parents all the way down, printing everything out. So it does not do the trees, but could you just as easily reconstruct the file system just like Git would from the trees? Sure, of course. Let me change this back to master, just so I can show you what that final result would look like. Oh, thank you. And now I'm just going to, I've skipped the other steps. This only does the Git log, but we're basically going to just say, here's what the final Git log would look like. And it looks very similar to a Git log that I had earlier. Basically, it starts at the top, works its way down. Could I actually have just done the rest of the Git functionality by saying, hey, look, I'm going to recreate the files that I see from head. If I do git check out this particular one right here, I could actually find the files there, look at those files, create them. What if I had a directory? How would that be represented? It would be another tree. Exactly. So yeah, so really we've understood everything. It's like finding Pokemon. There's only 3. I actually found one more the other day. It was called a tag type. I was like, oh my gosh. But there are basically 3 main objects that you're seeing all the time, 3 main types. Trees, super simple. You just follow them. Trees have other trees if they're directories. And inside, if they actually have files, they will have a blob. So you just have trees and blobs, and you just kind of reconstruct it. So you start there, okay, to read the other trees, then I'll start there, and I'll just keep recursively going down until everything has contents and filled in. So I actually can see how that's done. I can actually follow my Git flow as well. I can kind of see pretty much how everything is working underneath. Git points backwards, not forwards. If I was stuck, I'd simply go in and look. They're like, why is it someone has just deleted this commit? Well, is it in my repo? What's something pointing to? And the more you just draw that out as a picture, the more that all of those confusing things happen. And you can say, and this has happened to me before because a few times people can do crazy things. They love doing force pushes. Do you want to ever watch me, like at work, I'm a calm guy generally. I'm super cool. And someone says force push, they almost do it just to joke with me. And I'm like, what? And I jump up like a hee-haw or and yeah, they know that it drives me crazy. If I were to push, basically I would overwrite whatever's on the other server. Then they could break things for other people. What happened? Who did what? Let me go look at the structure underneath and find out. Well, you say, yeah, but that's all local, Glenn. I don't understand what's going on. Let's look. These refs things. Oh, wait, there's something called remotes as well. Happens to be there's something called origin. And there's something called master. And if I were to look at that, the answer is going to be surprised me as well.
Is someone in your computer?
Wait, which one is this? Ah, that's why. So I was like, wait, it's not supposed to be empty. Yeah, I expected it to be empty because I thought it was the one I made, but I actually just explored that this is actually from GitHub where I had actually explored. So I could actually see what GitHub has compared to what I have. I could reconstruct that command as well. Oh, I won't because I have security turned on. All right, so that's the basic idea. We've gone through, I think it wasn't as, I tried to make it as interactive as possible just so we could actually see this. So it's one of the most fun things I ever get in an interview is like when somebody's just like, really? It just, for some reason, it excites me. But it is interesting to see how simple Git is. It's not that hard. Once you understand a few basic tools. Head, it's just a text file. Refs, it's a directory with some stuff in it. Each of them are pointers. And then, you have objects, which is just all the collection of objects. So if I were to delete a branch, do I delete my objects? Now you understand the structure. I can throw all kinds of questions like this out there. Do I delete my objects? No, they're still there. What if I did a git reset head? I still don't delete my objects. They're all there. All I'm doing is changing the pointers. You can have things not being pointed to, and that's why you have garbage collection. And garbage collection also, when you garbage collect, you take these loose things and you put them into the pack file. I said we'll ignore pack. You actually cannot find some loose ones sometimes because once we garbage collect, and that's done with Git GC, and I won't do it now because there might be questions, but Git GC will take that and actually put it in your pack file and have an index for it. Whoops. I need to slow down again. Monkey, Git, refs, no object, sorry. And inside of object, there's a pack. And inside, and there's nothing because it's not been packed before, but there would be an index in a file if I pack it. So some of those loose objects can go away, and that's for efficiency. That's it. What do you think? Questions? It's super simple. Surprisingly simple. Everyone makes it such a big deal. How look how smart I am. I can do Git. It's not that hard. Just go look at it, draw a picture. Yeah.
So if you make a small change to a large file, does it keep 2 copies of that same file?
Yes.
Okay.
The question was, if you make 2 copies of a small file, does it make 2 copies of that file? Actually, I have to make a small caveat. If there are changes to the file, then yes, there are 2 copies. Like all abstractions, sometimes they leak. So I'm just going to say yes for the record, but there's some leakage here that I'll ignore, but yeah. But more specifically, what if I make a new commit? If I were to basically rebase or cherry pick or amend a commit. So if I were to look at a commit that I have, going too fast again. Yeah, if I were to go too fast, here we go. So back to monkey. So I know from a git log that I have this particular object right here. Okay, we're going to need to have that. So I'm going to echo it so we know to come find that one again. I'm going to amend. What does an amend do? So there are things that you can do that are really dangerous. Amending, rebasing, rebase interactive, all kinds of things. Amend is actually changing your Git history. Not yes, but not no. Locally, I've never pushed that, so there's no problem at all making a amend. And I'm simply going to say, I've changed the commit history. I've not changed the file. I've only changed the commit history. But if I do a git log, this is different than that. But what happened to this one? It's no longer accessible. But is it still there? Sure is. Oh. Oh, git, not cat. Yeah. But it's the wrong one. A9, is that the right one? Look, 2 different commit objects exist pointing to the same thing. One of them is accessible from the branches and one's not. So again, you can just go through. Great question. Another question. So we only have a couple minutes left. Yeah.
You were going to programmatically work with Git repositories. Would you use something like Git 2 or command tools or programming?
The question was, if I'm using Git repository, would I personally use several Git libraries, or would I use command line tools? And I have to say, my particular answer happens to be, and I don't know if this is the right or the wrong answer, but all of my coworkers happen to use command lines off of Git. So that's what we do because it's just so simple. I'm sure there's advantages to being able to use libraries, but honestly, there's so many things that we do that make sense to people that they're just so used to using it. But they're very Git friendly there. Yeah, any other questions?
We have 5 more minutes.
Oh, cool. Any other questions? Yeah, Jeff.
So when you ran the garbage, I get the idea the garbage collection is complete.
Yeah,
And you may have objects that no one references.
right.
So what is that pack collection for then?
Well, there are 2 things. I guess I'll do it now. So Git GC is a garbage collection, and so that's going to remove things. So it counted things up, it compressed some objects, and it's waiting for objects. And so now if I were to say cat file, it would still work, but I may not find that file on disk. But one of them may not work because it's not being referenced. Let's find out. So that cat file still exists, so it didn't clean it up yet. It's interesting. That one also exists, but if I were to say .git objects 5.1, what? Why is there no 5.1? What? They're all gone. What? So that's why I want to wait so we're done so that there was no confusion. But if I were to look, there's actually, did I do that? No. Let me make sure I didn't just lie to you by mistake. Objects, and inside of pack. And you'll notice now that the pack has certain things. There's a pack file and an index file. So this is your index file and your pack file. So now we had time to garbage collect. We've cleaned a lot of those loose files up and we put them into this packed format instead of loose format. But it's all still there. The reason I didn't pack it at first is I wanted you to see it's just a file. It's very accessible. This is all there for you. A great question. Let's do a git prune. And what was the other one? And I've never done this before. This will be interesting. Oh yeah, they're both there. I don't know why Git didn't clean those two ones up, but typically, you know, it will clean things up when it needs to, and I don't know what that algorithm is. But yeah, when you will find things disappear if they're no longer being referenced. Oh wait, is this one being referenced by the other branch? Oh yeah, I can't clean this one up. I don't think. And yeah, that's probably why we didn't see that one cleaned up. Great questions. Anything else? I'll just speak loudly.
Here, use the mic. That way everyone can hear.
I remember when you created the island branch, it was git branch, you were in master, and then you type git branch island. So basically what it does is like an alias or whatever, like it uses the same hash, so they're both pointing to the same area. So if you had two commits before, the island will have those two commits, correct?
Yes, it will. Now, to be a little precise. Oh, wait a second. Yes, it will, but just to be a bit more precise, actually, it really only cares about one commit, the very first one. Now, that commit has a parent, so it points to the previous one. So anytime you get the one commit, you'll always get its parents. You can't change them because to change them would change their SHA and their hash, and that's not allowed because that would change what they're pointing to. So that's why you're always having copies of things. So you just really have one commit, and that's all you need, an entire history. We have like 1 minute left or 2 minutes left. So there are lots of other things. Any other questions before I throw one more at you, just to squeeze as much as I can in?
Last question?
Last question.
All right.
You don't like force pushes, but what about force pushes against your own feature branch on remote?
That was quick.
That's just me. The question is force pushes against my own feature branch. No, because habits are good. It's just me. I mean, it's just to get people to see. You're right. If it's my own feature branch, who else is going to see it? I know. So everyone knows the only reason that a force push is bad is that you're changing someone else's history after they've looked at it. It's like if you have a particular book, and your book has a different edition than everyone else, and the teacher says, go turn to page 34. Well, everyone's going to go to page 34 except for this other person who's like, well, it's not on 34, it's on 35. So if everyone's history gets confused, that's where get hell comes from. That is really the source of get hell right there, that it alone. When the history for other people change compared to your own. So if you know that, look at their history, look at yours, trace back, and I've done this. We've actually had something really go bad, but we're able to fix it really quickly because we said, okay, well, we'll just take develop. We'll go back to here. And then we'll actually force push it so that everyone gets a new one. And then we'll actually reconstruct the history. And we'll ask everyone to check back to this point and pull forward. Very complicated, but we were able to do it very quickly and efficiently, and it didn't hurt anyone at all. In fact, we were able to get that in before most people even had the problem before. So anyhow, generally no though, because force pushing is bad, okay? It is, yeah, I'm not saying, it's just me. I won't argue the point. You're fair, I'm just being extra pedantic on something. Just for me to go crazy. All right, I think we actually still have 30 seconds.
Yes.
All right, so what would happen if I were to check out a particular branch? One last question for you. Just to squeeze as much value as you can out of the conference, and I don't know a particular hash, so I'm just going to pick this one, and I'm just going to say git check out this. That works just as much as, oh. Am I in the wrong place? Yes, I am. Up. I only have 30 seconds. No pressure. Pressure. Slow down. What just happened? I'm in git detached head state. What do you think head points to? Oh, sorry. What do you think that points to? It's always been ref something, other branch. It's just the hash. Cool. Thank you, everyone.